Okay, we continue for our non-rectangular polar case here. Okay, so we have two types, type 1 and type 2. Okay, type 1, region that is bounded by the rays, theta equals to alpha and theta equals to beta. Okay, so here for type 1, we have theta equals to alpha here. Here is theta equals to beta. Okay, so we notice that our alpha and beta here are constant. Okay, and then we have continuous polar curve r equals to g1. And then we have r equals to g2. Okay. Okay, so we can see that r is in terms of theta, okay, where we have a function g2 and also we have a function of g1, okay, which are not constant in this case. Okay, so for type 2, okay, a region that is bounded by the r equals to a and r equals to b, yeah. Okay, and then we have function h2, which is in terms of r here, and then also theta equals to h1, which is in terms of r here. Okay, so we can see that for type 2, our r, which is a and b, are constant. Okay, so we notice from here that type 1, we have value of theta which are constant, and values for r for type 2 are constant for type 2 region. Okay, here is the formula to find the area in polar coordinates, where our a here is area, which is double integral r dr d theta, okay, over region r. Okay, look at our example here. Okay, find the area of the region that lies inside the quadrant r equals to 1 plus cos theta, and outside the circle r equals to 1 in the first quadrant. Okay, so here is our graph. Okay, circle r equals to 1 here. Okay, so we have this graph, circle, red in color here. And then we have the quadrant graph, r was 1 plus cos theta, which is in the shape of heart. Okay, that is the quadrant. Okay, here is the circle. Okay, so inside the quadrant but outside of the circle. So the area is in orange in color here, shaded. First quadrant, so take notes, only first quadrant. Okay, so how are we going to find our area here? So area equals to double integral r d theta. Okay, so here we are going to find what is the limit of integration. Okay, what is the limit of integration? Okay, so look at our shaded region here. So our theta is from 0 to pi over 2. From 0 to pi over 2. So from 0 to pi over 2. Okay, well, for our radius here, okay, you look at our red arrow here. Okay, so this is our ray which is come out from the origin here. Okay, come out from our origin here. Okay, we have to identify which graph inner side and which graph outer side. Okay, so we can see our r equals to 1 here. The graph here is the inner one. Means the ray made this graph first. And then r equals to 1 plus cos theta is the outer graph. Okay, so our r should be from inner to outer. Means inner is 1. The outer is 1 plus cos theta. So our integral a equals to theta from 0 to pi over 2, r from 1 to 1 plus cos theta. Okay, so r dr d theta. Okay. Now we are going to integrate with respect to r first. So integrate r with respect to r, we get r squared over 2. Next, we have to substitute the value of r. So we are going to substitute the value of r. So one plus cos theta squared over 2 minus 1 squared over 2 d theta equals to okay, next simplify. So we get 1 plus 2 cos theta plus cos squared theta. Okay, minus 1 over 2. Okay, simplify this. So 1/2 minus becomes 0. 2 cos theta over 2 is cos theta plus cos squared theta over 2. Okay, d theta. Okay, now we are going to integrate with respect to theta, but we have problem here, so we have to apply trigo formula. Okay, the formula that we are going to apply here. Okay, cos squared theta. Okay, the formula from cos 2 theta. Okay, cos 2 theta equals to 2 cos squared theta minus 1. Okay, so 2 cos squared theta equals to 1 plus cos 2 theta. Okay, so cos squared theta equals to 1 over 2 plus cos 2 theta over 2. Okay, so here we have cos squared theta over 2. Okay, here. So divide by 2 here becomes 1 over 4 plus cos 2 theta over 4. Okay, so take this. Okay, and then put into the circle here. So cos theta plus 1 over 4 plus cos 2 theta over 4. Okay, 3 theta. Okay, next we are going to integrate directly from here. So we get cos theta integrate with respect to theta is sine theta plus 1 over 4 theta plus sine 2 theta over 4 times 2 is 8. Okay, next we are going to substitute the value. So we are going to substitute the value. Okay, so sine pi over 2 plus 1 over 4 pi over 2 plus 1 over 8 sine 2 pi over 2. Okay, and minus 0 plus 0 plus 0. Okay, so sine pi over 2 equals to 1. Okay, so sine pi equals to 0, so this one 0. So equals to 1 plus pi over 8. Okay, finish.